There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb, and today we're going to be taking a look at pixel number base. This module is a little bit of a rarer one to actually see anywhere besides Twitch Plays. I don't think many people actually use it for missions as of this recording, as the time is recording. But essentially what we're going to be doing is we're going to be converting a series of 16 of these little grids, these little 4x4 grids, into a series of characters in hexadecimal. So, what we're going to be doing is we're going to be using the colors of the pixels, and the highest value pixel will be located in the top left of each character. So there will be 4 different bits of data, as we can see here, separated by the little boxes that they're in. And essentially what we're going to be doing is these are all in base 2, and we're going to be turning this into base 16 or hexadecimal. So taking a look here, let's see what the manual says. So the highest value pixel in the bitmap is located in the top left, and the lowest value pixel in the bitmap is located in the bottom right. Starting from the bottom right, we're going to be moving left. Moving left will represent a higher bit. So this one down in the bottom right here, it's a grid of 4x4. So we have this. Take a look at the second one, for example. We have the bottom right, and it's going to keep increasing left by 1, and so on and so forth. So, after reaching the leftmost pixel bit of the line, moving up, and starting from the right, continues each value. Each pixel represents base 2, and each bit should be represented in base 65536. Whoa, that's a rather quite large number, which I actually want to break this apart, and I really want to make this really, really easy, because there is a huge method that will just make your life so much simpler, and almost in a way will be a solo, but I will explain why it's not a solo. Garbage truck outside. So I'll explain why it is a little bit of a solo in this case, but it's you're gonna want the expert to help you with you on this in case if you're doing this on voice. And a black pixel will represent an active cell, or in this case for base 2, black represents 1, K represents 1, and white represents an inactive cell, or 0. To solve the module, we're going to be calculating the value of all the bitmaps and convert the resulting number into hexadecimal. So this is going to be how hexadecimal works. So for those who aren't familiar with how hexadecimal works, to give you a better idea, we're currently using the decimal system, which is referred to as base 10. Base 10 is simply just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like so. Now base 16 works off of base 10, but it simply adds on A, B, C, D, E, F. And what these values equal, A is simply equal to 10, Bravo is equal to 11, Charlie 12, Delta 13, Echo 14, Foxtrot 15. So it's 16 different numbers, with the highest being 1 less than the actual base it is in, i.e. 15. And just like that, that means we have 16 different numbers, including 0. Excuse me for just a second. Alright, sorry about that. There's just a garbage truck outside. So, as I was saying, base 16 is going to consist of these characters, with A through F being added on here. So, and remember that A is equal to 10, or a simple way of calculating this is taking its alphanumeric position and simply adding 9 to it. So, for example, alpha is in the first position, A is simply 1 plus 9 will simply give us 10, and that is equal to 10 in base 16. Simple way of remembering that. So, the easiest way that I'm going to break this up to you is actually not going to be too difficult. All you're simply going to be doing is you're going to be converting from base 2, the binary of each row, into base 16. And that's really the way that you're going to do this. Instead of getting all of your numbers like 1, 0, 0, 1, 1, 1, 0, 1, 0, so on and so forth, all the way for each bit here, what we're simply going to do is we're simply going to go row by row, and we're simply going to calculate each character in the hexadecimal value. So, for example, this first one that we have here, and for those of you who don't know how base 2 works, essentially what we're going to do is we're going to, it's going to be 2 to the power of 3 is our maximum, so 2 to the power of 3, then 2 to the power of 2, then 2 to the power of 1, then 2 to the power of 0. And so, essentially what's going to happen is each of these values, 2 to the power of 3 is equal to 8, 2 to the power of 2 is equal to 4, 2 to the power of 1 is equal to 2, and then 2 to the power of 0 is equal to 1. Essentially, if one of these squares is black from left to right, that's simply what we're going to apply, and we're going to add these guys together and simply convert them into base 16. So for this first example, we have the first bit and the fourth bit, so that's going to be 8 and then 1, that's going to give us our value of 9. And that's all we're going to do for that row. And we've already converted it into hexadecimal for this first row. And we're going to do this for each 16. Unfortunately, it's like this. It's a bit annoying, but it's just the way it is. So next up, we have, for the second row, we have 8, 4, and 2. 8, 4, and 2 is going to give us 14. 14 is going to be, that'll be an echo. So that'll be a 5, that'll be 5 plus 9 will give us 14 as an echo, and that'll be our second character. Next two characters, the only one is going to be number 2. So it's going to be the 2 to the power of 1. So that's going to be simply 2, so 2, 2. And we're already done with the first bit. Next up, we have 8, 4, and 1. 8, 4, and 1 is going to give us 13. So 8 plus 4 is 12, and then 12 plus 1 is 13. That's going to give us a 13, which is a delta. 4 plus 9, giving us 13. Delta is going to be our second character. Next up is simply just 1. The fourth position is simply just going to give us 1. Pretty straightforward. Then next up we have 8 and 4. It's simply the first row of this second bitmap here, and it's going to be just simply us subtracting 1, so it's going to be a Charlie. And then 8 and 2 is going to be 10, which is going to be alpha. Then we're simply just, I'm going to go through this for the next little bit here. As long as you understand how to do base 2 to base 10 at least, and then base 10 to base 16, you'll be good to go. This is a very easy module. However, it looks a little intimidating by the manual because base 6, 5, 5, 3, 6, not really what we want to be doing here. But essentially what we're going to get is we're going to get a series of 16 digits, and that's how, and then we're going to input this into the module. Now, the reason why this is technically not a solo is the second you start inputting any sort of characters into the module, the actual screen disappears. It doesn't pop up in the bottom of the display, unfortunately. It simply disappears from the entire screen. So each of these bitmaps will disappear, and you'll have to press the reset button. And note that the reset button completely resets the entire sequence, meaning you'll get a different puzzle here. So keep that in mind. So for the next bit, we have 3, because it's 2 plus 1 equals 3. Then it's going to be 3 plus 8, essentially, is going to give us 11, so that's a Bravo. Then we have 2, and then we have Foxtrot, and then we have 3 again. 8 plus 4 plus 2, we've had this before, is going to be a Echo. 4 plus 2 plus 1 is going to give me 7, and then finally a 1. So now we're going to submit these guys into the module, so we have 9 Echo, 2, 2, then Delta 1, Charlie Alpha, 3 Bravo, 2 Foxtrot, 3 Echo, 7, and once you press this last one, that's when it will count as submission. And just like that is a solved module. So it's a nice, easy way to break this apart instead of looking at the manual as complicated as it is. It's a very simple way to do it. And note that it actually provides you an example of which you can follow along with me. For example, this first row, 8 plus 4 plus 2 plus 1, that's our maximum. That's going to be Foxtrot, which is the highest character in base 16. Like so, Foxtrot. And then second row, 8 plus 1 will give us a 9. Like so. And then 4 plus 1 will give us a 5. And you'll see that this is just a simple way of this making sense. So let's take a look at one more example, and hopefully you understand what's going on by now. And I'm going to go through this a little bit quicker because this module is pretty straightforward, and there really is not much to it. But I will show you what I mean by the reset button changing how it looks. Let's load up. There we go. It's a bit of a weirder module, it's not used that often, but it's really simple to break apart, and it's not really that complicated at all. It's a very nice little solo. So if I press the reset button, it'll completely reset the entire display. If you have to press 2, it'll reset the entire display, so on and so forth. Let's go through this pretty quickly. So we have 3, 8 plus 2 is going to be 10, so alpha. 8 plus 4 is going to be a 12, which is going to be Charlie. Then we have 1. Whenever the lights decide to turn back on. Thank you very much. Remember black pixels represent 1s and white pixels represent 0s, so just keep that in mind. Then we have 4 plus 2 is going to be 6. Then 8 plus 4 is going to be a 12, which is going to be a Charlie. We've had that one before. Then there's no black X's in this one, so that's actually going to be 0. Then for the fourth row in the second bit is going to be 4 plus 2 is going to be 6. Had that one before up at the first row. Simple as that. Next up is going to be just simply 1. 8 plus 2 is going to be 10, which is an alpha. 1 again. Then 8 plus 2 plus 1 is going to be 11, which is going to be a Bravo. And for our last little bit here, we have 8 plus 4 plus 1, which is going to be 13, because 8 plus 4 is 12, plus 1 is 13. That is going to be equal to delta, because delta is going to be 4 plus 9, alphanumeric position. Alphanumeric 4 plus 9 gives us 13. Then we have 8 plus 4 plus 2, which is going to be an echo. That is simply going to be 14, which is 5 plus 9 equals 14. Then we have 4 plus 2 is 6. And then we have 4 plus 2 plus 1, which is going to be a 7. And now let's simply submit this into the module. So let's do that. So we have 3 alpha, Charlie 1, 6 Charlie, 0 6, 1 alpha, 1 Bravo, delta echo, 6 7. And once we hit that 7,
Is the right answer.
just like that, is a solved module. So the way that I mean that it's a solo is because of the fact that you can simply just read these off to your expert like nothing at all, and they can simply give it right back to you. So, as always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye. Happy holidays.